Good morning, children. Hope you all saw your test marks. I would say the performance was fair, not very good, not very bad, but fair. Being the first test, it's okay. Kindly start studying more carefully and start scoring better marks. There were still children who cheated, and I had to give them zero. I don't want to tell the names, but they got a zero. Okay, so please don't ever try to cheat. Whatever you know, please write it. Anyway, the board exam you have to come and write in the school, and you're not going to cheat. You cannot do that. Remember, not only board exam, we don't know even the other exams. For exams you might have to come to school and give the exam, we don't know it, but then you're not going to have Zoom test forever. Don't just get used to copying. I think because you know that you can copy, you're not studying also. You just think that okay, we can think of various ways to hide your book or notebook and do cheating during test, get some marks. That's enough. You're cheating yourself, remember that. Okay, now we have done till numerical number 19. We'll be starting numerical number 20. Okay. So this 20 to 31 is a is of a is of a different type. Okay. So before doing that, we should see some conclusions related to series and parallel circuit, which we have not yet seen. So come back to page 191. So, I told you this, when the resistance has to be increased, we'll put them in series, and when resistance of the combination has to be decreased, we put them in parallel. Okay, when you put them in series, the total resistance will increase. When you put them in parallel, total resistance will decrease. Okay, then combination of resistors. So this is series combination. Taken three resistors R1, R2 and R3. You don't have the derivation. Okay, you don't have the derivation, but these two conclusions you're supposed to know. What do these conclusions say? Current has a single path for its flow. Therefore, same current passes through each resistor. Current I flowing through will be the same through each and every resistors. Same current. Suppose if it is 1 amp, through this also 1 amp, through this also 1 amp, and through this also 1 amp will go. Okay, in series current is same, but potential difference across the entire circuit is equal to the sum of potential difference across the individual resistors. Now, across each resistor, potential difference will be different. Potential difference across R1 will be I into R1. Potential difference across R2, I into R2. Potential difference across R3, I into R3. But when you add all these three potential differences, V1 plus V2 plus V3, it will be equal to V. Okay, whatever supply voltage you gave, it got dropped here, here and here. Okay, so V will be, so in series current will remain the same, but potential difference will be different. Voltage will be different. Voltage across each resistor will be different, but I will be same. In parallel, it's just the opposite. Okay, so you can strike off the derivation part. Okay, so you can strike off till this. You just have to know the conclusion. Rs is equal to n into, Rs is equal to R1 plus R2 plus up to Rn. Even if you have any number of resistors, just add them. Now, combination of resistors in parallel. This is how the circuit will look. And what are the two conclusions in this? In this, current will be different. In each of these parallel path, current will be different. If I is the total current, it's like I told you, branching, it will split into three paths. So different currents will go through these three paths, I1, I2, I3. But potential difference will be the same. Potential difference across R1, R2 and R3. That is V1, V2, V3 will be equal to V itself, that is the battery. Okay, so these two conclusions you should remember. In series, current is the same, voltage is different, a potential drop across each resistor is different. In parallel, current will be different, but potential drop across each resistor will be the same. Hope you understood this two conclusions. So put a tick mark on these two conclusions. This is what is given here. And then expression, again derivation is not there, so you can cut off the derivation part and come straight to the conclusion. 1 by Rp is equal to 1 by R1 plus 1 by R2. You can have any number of resistors they have taken generally. This is the expression. Okay, then combination of series and parallel, you know that how to solve it. Now there are some conclusions that you should know. If two resistors are connected in series, the equivalent resistance is more when they are joined in parallel. So if I have to show a VI graph, now I would at this point I would like to stop here, and I want to discuss the last question of yesterday's test. Last question, 8th question of yesterday's test. The question was, draw IV graph of two conductors at two different temperatures. Okay, at two different temperatures, and what conclusion do you get about the temperature? Now in your book what they have given is VI graph. Now most of you had drawn this graph. Okay, you had drawn this graph and said T1 is greater than T2. No, this is VI graph. But what I had asked was IV graph. So what will happen? It will be totally opposite, I and V. So in an IV graph, suppose this is temperature T1, this is temperature T2. So slope of IV graph gives you what? 1 upon resistance. Slope of IV graph gives 1 upon resistance. So steeper the slope, less will be the resistance. In case of IV graph, if it was VI graph, then you will say steeper the slope, more will be the resistance. So here the second conclusion is steeper the slope, less will be the resistance. So what does it mean? This means resistance of this is less than, okay, let's take A and B. This means resistance of A is less than resistance of B. Or if I have to talk about the temperature, I can say T1, therefore T1 is less than T2. The conclusion is T1 is less than T2 because resistance is directly proportional to temperature. Because RA is less than RB, T1 will be less than T2. What you had in your book, you had the opposite conclusion. T1 was greater than T2. Understood, children? So this was one thing most of you had made a mistake. Okay, please note the correction. See carefully whether it is IV graph or VA graph. Okay, now this has this part, okay, has IV graph of two circuits, one in series and the other one in parallel. Okay, now so IV graph. Okay, so for parallel combination, you know that total resistance in parallel will be less and in series it will be more. Okay, and IV slope gives inverse of resistance. That means the more steeper one will be parallel and the less steeper one will be series. So this line is of parallel, this line is of series circuit. If it would have been VI, it would have been just the opposite. If they would have given you a VI graph, then the steeper one will have more resistance, that will be series, and the parallel, the less steeper one will have less resistance, and that should have been parallel. Are you able to see the difference, children? IV and VI, exactly, they'll be opposite. Okay, so this also comes in question. Sometimes you can put a tick mark here, VI graph for series and parallel combination. Rest all are fine. Now we will quickly go to numericals based on this, all these concepts that we saw. Okay, so we'll be doing numerical number 21 first. Please turn to page 202, numerical number 21. Okay, you have to solve it along with me in your notebooks. So please don't copy it, but try to understand it and then solve it. A resistor 6 ohm is connected in series with another resistor 4 ohm. A potential difference of 20 volt is applied across the combination. Calculate current in the circuit and potential difference across 6 ohm resistor. A 6 ohm resistor is connected in series with another 4 ohm resistor. One 6 ohm resistor and 4 ohm resistor, they are connected in series and they are applied across a combination of 20 volt. 20 volt. Okay, so if nothing is mentioned about internal resistance, then there is no internal resistance. Okay, your E, V, everything will be the same, so don't worry. Okay, calculate current in the circuit and potential difference across 6 ohm resistor. Potential difference across 6 ohm resistor. Let's take V6 ohm. Okay, potential difference across 6 ohm, or PD across 6 ohm resistor is also okay. PD across 6 ohm resistor, because PD across 6 ohm will be different, PD across 4 ohm will be different. Okay, so this is the question mark. So first, how will you find the current? Because there is no EMF or internal resistance, we will just use the formula V by R. E by R plus R will come only when there is internal resistance. So our V is 20. Now what about capital R, that is external resistance? You have two resistors in series. So RS will be 6 plus 4, that is 10 ohm. So this R is R equivalent or R total. Total resistance you have to take, not a single resistance. When you find the current, you have to take the total resistance. So V by R total or RT, that is 10 ohm. So 20 by 10, that is 2 ampere. So current is 2 ampere. That's the first part. Then they ask you to find potential difference across 6 ohm resistor. That will be, V is I into R, and here because across 6 ohm, I is 2 and only 6. Don't write 10, don't write 4, you have to write only 6 because you have to find the potential difference across 6 ohm resistor. So for that, I into R, that 6 ohm alone. Okay, so 2 into 6, 12 volt will be the potential difference across 6 ohm resistor. By chance, if they ask you to find potential difference across 4 ohm resistor, you should have written 2 into 4. Current will be the same. Okay, so it is 8 volt. Now if you add these two, okay, so that will be equal to 20. That will be equal to 20. V is equal to V1 plus V2. Is it clear? So this is how this has to be solved. Now come to 22. Two resistors of resistance 4 ohm and 6 ohm are connected in parallel. So 4 ohm and 6 ohm are connected in parallel across to a cell to draw current of 0.5 ampere from the cell. So connected to a cell and it takes a current of 0.5 ampere. Takes a current of 0.5 ampere. Draw a label diagram of the arrangement. Calculate the current in each resistor. You have to find this one I1 and I2. Total current they have given, and you have to find I1 and I2. Now, you don't know the potential difference means. Terminal voltage V, you don't know. First you find that. To find the terminal voltage, you need to take the total resistance. So because it is parallel, okay, so 1 by RT will be 1 by R parallel, which is equal to 1 by 4 plus 1 by 6. Sorry, RT will be, okay, to find RT, I have to find R parallel, and 12, 4 into 3, 1 into 3, 3 plus 2, 1 by RP. Our RP will be 12 by 5, that is 2.4 ohm. Okay, so our total will be 2.4 ohm. So I know the R total. Now in this, see, you know potential difference and you knew total resistance. Then you found the total current by V by RT. I is equal to V by RT. Now in this, you know the total current, you know the total resistance, and you have to find the voltage. Okay, the supplied voltage. So V is equal to I into RT. V is equal to I into RT. So our current is 0.5 and our total is 2.4. So this will be okay. 5 fours are 20. 1.2 volts. So this V, the battery voltage is 1.2 volts. Is it clear, children? So this is how you have to find. Okay, so we'll find V first. Then after finding V, I have to find I1 and I2. I1 is equal to V by R1. Okay, so V will be the same. Potential difference across this is also 1.4, across this will also 1.2, across this also is 1.2. So current here will be this V by R1. Current here will be V by R2. So V is 1.2 upon resistance 1 is 4, because I1 is the current going here. So that will be 0.3 ampere. I2 will be V upon R2, that will be 1.2 upon R2 is 6, that will be 0.2 ampere. Okay, so these are the two currents, and for verification you can add I1 and I2 and see whether you're getting 0.5. Of course, 0.3 plus 0.2 is equal to 0.5, that is the total current I. So your answer is correct. Is it clear, children? So these basic concepts you have to understand. If it is given in series, if it is given in parallel, how to solve it. I hope you understood it clearly. Yeah? Okay. We'll do one or two more sums and then I'll be giving you homework. So after 22, we go to 24. We go to 24th question. Okay. 24th. In the circuit, in figure 8.5, to calculate total resistance of the circuit, value of R, current flowing in R. So they have given us circuit. And the current they have given us 0.4 ampere. This is voltmeter is showing 4 volts and 20 ohm. and R. Okay. So total resistance, what all we have to find? First we have to find total resistance of the circuit. Total resistance of the circuit. Second one, value of R, this unknown resistor R. Then C, we have to find current flowing through R. So total current 0.4 amp, this ammeter is showing 0.4 amps. What does it mean? The current, total current is 0.4 ampere. The previous one we had 0.5, same way. Here the total current is 0.4 ampere, which will divide into I1 and I2 because they are in parallel. So we have to find I1, I2 because they have asked to find the current across R. So we have to find I2. Is it clear, children? So now R total we have to find. Now if you see in this, we know V and we know I. Okay. So we know that V is equal to I into R total. Okay. So R total will be V by I. So my V is 4, I is 0.4. So it will be 10 ohms. So R total, the total resistance of the circuit is 10 ohm. Have you understood? In this case, we know V and I. In the previous two cases, okay, we knew different things. In this case, we know V and I, and we have to find the total resistance. For that, you use RT is equal to V by I. Now, this RT is different from this R. RT is the total resistance. This parallel combination ka total resistance is RT. Okay. Second one, we have to find R. Now, RT, you know, this one resistor, you know, so you have to find the other resistor. So we know that because it is parallel, 1 by RT will be 1 by 20 plus 1 by R. Now that RT is 10, which we have already found. So 1 by 20 plus 1 by R, or 1 by R is equal to 1 by 10 minus 1 by 20. So 20 if I take LCM, 2 minus 1 is equal to 1 by R. 1 by 20 is equal to 1 by R, or R is equal to 20 ohm. So this resistor R is 20 ohm. Okay. This is also 20 and this is also 20 ohm. Is it clear, children? And then the third part, we have to find I2. I2 will be V by R2. R2 here is 20 ohm. So V by 20, 4 by 20, that is 1 by 5, 0.2 ampere. Okay, the current that is going here, anyway, because both are 20 ohm, here also the same current will be going, 0.2 amp. 0.2 plus 0.2 gives 0.4. I hope you're clear with this concept. Yeah. So okay. Now we have another type of numerical. So with that, this exercise will be finishing. So I will just do one of that and then the others will be homework. 28. Now in these numericals, we didn't talk about EMF and internal resistance, so it was quite simple. Now in this kind of circuit itself, if you have EMF and internal resistance, then things will go a little complicated. Let's see that. Okay, so 28. The circuit diagram in figure shows three resistors, 2 ohm, 4 ohm and R ohm, connected. Sorry, let's not do 28. I'll do 31, children. Oh, sorry, 27 I'll do. 27. A battery of EMF 15 volt and internal resistance 3 ohm. So internal resistance 3 ohm are connected to two resistances 3 ohm and 6 ohm in parallel. 3 ohm and 6 ohm connected in parallel. Find the current through the battery. This is the circuit. What all we have to find? I, total current I we have to find. Second, PD across the terminals of the cell. PD means terminal voltage. PD across terminals of the cell means terminal voltage, because this will be EMF, because they have given, yeah, it is given EMF as, so they are asking you to find terminal voltage V, capital V. Then the third one, you have to find current in 3 ohm resistor. Current in 3 ohm resistor. And fourth one, current in 6 ohm resistor. These are the four things we have to find. Okay. So, if it is EMF, you know the formula for I will become E upon R plus R. Okay. Now, our capital R, the external circuit, is basically the parallel combination. So, for R, we have to consider this parallel combination, that will be 1 by 3 plus 1 by 6. So 2 plus 1, 3, or RP will be 6 by 3, that is 2 ohms. Okay, your total resistance, external resistance is R, that will be R parallel, that will be 2 ohm. So now I is equal to 15 upon capital R, I will take it as 2, small r is given as 3 ohm. So 15 by 5, that is 3 ampere. So I is equal to 3 ampere. So this is the first part. Second part, terminal voltage. So V is equal to, either you can write I into capital R. So I is 3, our capital R is 2, that is 6 volts. Okay, EMF is 15 volt, but terminal voltage is only 6 volts. Okay, so much of voltage, 9 volt is wasted in the battery itself to overcome its resistance. Then the third one, current through 3 ohm resistor. Current through 3 ohm resistor. Now when you find current through 3 ohm resistor, so I is equal to V by R. We have to take terminal voltage. Okay, don't take EMF. You have to take the terminal voltage here. Don't forget it. Terminal voltage upon resistor. So terminal voltage is 6 volt upon, because we have to find current through 3 ohm. You take the 3, 6 by 3, that is 2 ampere. Please don't take 15 here. Okay, so current through 3 ohm, if you have to find these individual currents, you have to take terminal voltage. When current is flowing, what will be the potential difference across this? That will be terminal voltage, not the EMF. Only when current was not flowing, this was the thing. Okay, so you have to take terminal voltage V and use that to find here. Then fourth one, current through 6 ohm resistor, again V by R, that is 6 by 6, that is 1 ampere. And if you add these two, 2 plus 1, you get 3 ampere total. Okay, children. So this is how you have to solve if you have a EMF and terminal voltage. Okay, please note down the homework. 20, 23, 20, 23, 26, 25 is cancelled, children. You can just strike it off. It is not there. 26, 29. Okay, I had to do this. 29 and 31. Okay. I think you leave 29 and 31. Okay. So 20, 23, 26. 20, 23 and 26. I might be giving 1 or 2 extra numericals in the MCB. Thank you, children.